Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal, lecture number 22 on chemical kinetics. In this lecture, I will explain numericals for determination of order of reaction. Okay, so let us take one first example to find out order of reaction. Okay, the reaction is ammonium cyanate on heating decompose to give urea. Now, table is given, time in minutes, and a minus x is given to you. At 0 time, a minus x, where x will be 0. So this is in fact a. This is equal to a, and that is 0.0916. Then after at 45 minutes, it is 0.074. At 72 minutes, the a minus x value is 0.0656. At 157 minutes, it is 0.0572. At 312 minutes, it is 0.0348. And we have to find out order of reaction. Here we will use integration rate method. Okay, so the method which is applied will be integration rate law. Integration rate law method. Where we use a different k of different integrations to find out in which conditions the value of k is constant. So let us prepare a table. Time, here it is given 45, then 157, then 45 and then 72, then 157 and 312. And here a minus x is given. A minus x at 45 minutes is 0.0740. At 72 it is 0.0656. At 157 minutes it is 0.05157. Is it 512 or 572? Oh, sorry. It must be 512. So it is 512, and at 312 minutes it is 0.0348. In this case, A is equal to 0.0916. That you remember. Now, as you know, A and A minus X, you can find out X also. So X for this one will be 0.0916 minus 0.0474, and that is why it is 0.0176. For 72 minutes, 0.0916 minus 0.0656, it will be 0.0260. 0.0916 minus 0.0512, so it would be 0.0404. And 0.0916 minus 0.0348 is equal to 0.308. 568. Okay, so these are x at different times. Now we can apply k is equal to 2.303 upon t log a upon a minus x, or k is equal to 1 upon at x upon a minus x. This is for first order, and this is for second order. Okay, so if the value of k1, k2, k3 and k4, if k1 is equal to k2 is equal to k3 is equal to k4, then it follows first order. If not, then try for this one. So we can write k5, k6, k7, k8. So if k5 is equal to k6 is equal to k7 is equal to k8, then it follows second order. Or we can try for third order also. Okay, so this way we can find out the order of reaction using integration rate law method. Okay, so this is an example related to this one. Now next numerical, let us take this one. At certain temperature, the half-life periods for the catalytic decomposition of ammonia were found to below. Here the table is given, pressure is given in mm, and T half is also given. So at 50 mm pressure, the T half is 3.52. At 100 mm pressure, T half is 1.92. At 200 pressure, T half is about 1.0. So here T half is given, so we can use half-life period method to find out order of reaction. So half-life period method is T1 upon T2 is equal to A2 upon A1 raised to n minus 1, or as pressure is given, so we can write P2 upon P1 raised to n minus 1. Okay, so for first pair, we can write P1 is equal to 50 mm, P2 is equal to 100 mm, T1 will be 3.52 and T2 is 1.92. So here we can substitute these values. So in T1 upon T2 is equal to P2 upon P1 raised to n minus 1. Okay, so we can take 3.52 upon 1.92 is equal to 100 upon 50 raised to n minus 1. Now if we want to take log, then we can find out n. So we can take log of 3.52 upon 1.92 is equal to n minus 1 log 2. Okay, so this way you can find out n. N would be whatever the value is. It can be fractional value, but if it is greater than 1.5, then you can consider 2, and if it is less than 1.5, it will be 1. Okay, so this way we can find out n. Now for second pair, P1 is equal to 100, where T1 will be 1.92 and P2 will be 200, where T2 is equal to 1. Okay, now substitute these values also in T1 upon T2 is equal to P2 upon P1 raised to n minus 1. Okay, so 1.92 upon 1 is equal to 200 upon 100 raised to n minus 1. Therefore 1.92 is equal to, log of 1.92 is equal to n minus 1 log of 2. Okay, and here also you will get n. So n would be 1, 2, 3, whatever you have to find out. Okay, so this way we can use half-life period method to determine order of reaction. That's it in this lecture. Thank you.